Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the May-June 2015 Pure Mathematics P1 paper from Cambridge. This is paper 1, variant 2, the 9709 syllabus. And this is a question that I have in one of my end of lesson test your understanding exercises. And one of my students has asked me about this question. And there's some aspects of this question which he wanted to find out a bit more about. So I'm going to go through this question. So the question tells us that in the diagram, AYB is a semicircle. So AYB is a semicircle. So AYB is basically this. Let me try and get this as a highlighter pen. AYB is basically this semicircle here. All right, so that's a semicircle. And AB is the diameter. Okay, so that's a semicircle here, this whole thing, right? And then it says OAXB is a sector of a circle with center O and radius R. Okay, so we have AOXB, which is basically this sector here. It looks like the slice of a pizza. Okay, this is the sector OAXB, and it has a radius R. And it has center O, and the angle AOB is 2 theta radians. So we've got to find an expression in terms of R and theta for the area of the shaded region. So we've got to find this shaded area over here. Okay, so how we can do that, if we look at this diagram, is basically if we consider the semicircle AYB, and we take away from the semicircle this area over here. This is the area of the segment OAB, the segment. Okay, the segment is like this part of this sector. Okay, so we need two things. We need the area of the segment, and we need the area of the semicircle. As for the segment, we have everything we need. The area of a segment is basically the area of the whole sector minus the area of the triangle. So the formula, if you memorize the formula as it is, like as one thing, is it going to be a half R squared theta minus sine of theta. That's not in the formula sheet. We have to know that, okay? But where does it come from? It comes from the area of the whole sector, which is a half R squared theta. Now the theta I'm talking about here is the theta in the formula sheet, not the theta, not this angle here. Okay, a half R squared of the angle that makes it 6. So I'll draw a little sector here to make it clear. We're talking about the general formula. Okay, so that theta here, the formula sheet represents the angle. Here the angle is 2 theta. We're going to have to replace this with 2 theta when we use it in our question. But just generally, this is the general formula for the area of a segment. So it's the area of this whole sector, half R squared theta, minus the area of this triangle. If you take away the triangle area from the sector area, you're left with the segment area. Okay, that's what you're left with. So the area of a triangle is a half AB sine C. A half times R times the sine of the angle between them. That's a half R squared sine theta. So if we just factorize this, take half R squared out as common, we're left with this formula. This is the formula for the area of a sector with radius R and with angle, so area of a segment, segment, radius R and angle theta. Okay, so we can find the area of this sector, and we have everything we need to find the area of this sector. Okay, that's fine. The issue now is to find the area of this circle from which we subtract the area of this segment from. So if we can find the area of this segment, we need to find the area of the semicircle now. Now the semicircle doesn't have a radius of R. This R is not the radius of this semicircle. Okay, this semicircle, AB is its diameter. So the semicircle, its center is going to be over here, halfway between A and B. Okay, that's going to be the center, and the distance between A and the center, let's call that point, for example, let's say P. So AP is a radius, or BP is a radius. Okay, that's what we need to find. So how do we find this? Now, there's a couple of different ways we could use, and the student that was asking me was thinking about using the cosine rule and then dividing the distance AB. Find AB using the cosine rule because we have two sides, and we have the angle between the two sides. Okay, so we can use, you know, you can use basically, well, in terms of the sine, the cosine rule, this would be A, this would be B, this would be C. So A squared equals B squared plus C squared minus 2BC times cosine of the angle between them. Okay, so that would be A, that would be B, that would be C, and you would find the area of the length of the whole line AB by using the cosine rule. Okay, you could do that, but it's going to leave us with something that's kind of a bit complicated in terms of the expression that we have. All right, so I would favor finding the length of this by drawing a perpendicular line from O. It's going to cut, if it cuts this exactly at the center, it's going to cut this into 2 equal halves, right? And we can call this X from here to here. So we can say AP is equal to X. And we can find this X using the fact that this is a right angle triangle. And, you know, we have the hypotenuse, and this angle will be bisected into 2 halves. This angle will be theta, and there will be theta here. So we can use this triangle over here, okay, to find the value of the radius. We can use this triangle over here, and that will give us a much easier expression to use. So we can say sine of theta is equal to X over R. So X is equal to R sine theta. So that's the radius of our main circle, the big circle, AYB. Okay, so we can then go on to solve the question. So I need to find the area of the shaded part, which is like that crescent shape. And that's equal to the area of the semicircle minus the area of the segment. Okay, the segment. So this is going to be the area of the semicircle. Now the area of a circle is given by pi r squared. So area of a semicircle will be pi r squared over 2. This will be pi times r squared. Now the r in our case, the is our x. Okay, so the radius of AYB is x, which is r sine theta. Okay, x is r sine theta. So it's going to be pi times r squared. So it'll be r sine theta squared divided by 2. That's the area of the semicircle minus the area of the sector. And as we said, that's going to be a half times r squared. Now the radius of this is just r squared times the angle. Now the angle is 2 theta minus the sine of 2 theta. Okay, and this will give us our expression, and that will be our answer. So we could just expand this. So we'll have a half times pi times r squared times sine squared theta minus and a half times r squared. Okay, that's going to be r squared 2 theta. So it's going to be a half r squared times 2 theta. So you're going to have basically 2 r squared theta over 2, and minus times minus is plus a half r squared theta times sine of 2 theta. Okay, so that is basically our area that can simplify. So we have a half pi r squared sine squared theta minus r squared theta plus a half r squared sine of 2 theta. And that's, I think, as simple as you can get here. And here we have the answer. All right. Now, the question didn't give us a particular format to write it in. So we can leave it like this. It might have given it, for example, it might ask you to give it in a factorized manner where, for example, you could take a half and r squared out. So it might have asked you to write it in a certain form where it's factorized. So half and r squared is common. Okay, which will leave you here with pi sine squared theta minus, you'd have to put 2 here, 2 r squared theta plus r squared sine of 2 theta. But it didn't ask you that. So if you left it like this, it would probably be safer. Now, as for the method of trying to find this length AB using the cosine rule, So you'd say that basically AB, okay, AB squared. So AB would therefore be the square root of, you'd have r squared plus r squared minus 2 times r times cosine of 2 theta. This will give us basically the square root of 2r squared minus 2r squared cosine of 2 theta. Now, that doesn't look very much like the same as r sine theta. Okay, it doesn't look the same as r sine theta, right? But in fact, this will simplify to this, okay? But in P1, we don't have the knowledge to simplify, okay? Now, I'm going to just to prove it to you, although you don't need to know this, and this is your answer, that's fine. And if you left your answer in terms of, this as being AB, you'd have to divide it by 2. That would be the radius then, because we found AB. And then you would have to use this instead of here. So you'd have pi times all of this squared, okay? And then divided by 2. And it will look a bit, complicated. So that's why it's much easier to leave your answer in this form. Okay, so find the radius by using this right angle triangle easier. But I'm going to show you. So if you did write it in that form, if you did write your answer as basically the same things here, but this would be pi times all of this squared. So basically the square root would disappear. You have 2r squared minus 2r squared cosine of 2 theta over 4, okay? And that would be basically your area of the circle. And from that, you would then subtract the same things that we subtracted there. And that would be equivalent to the answer. Okay, that would be fine. But it looks a bit weird and it's not in the answer scheme like this. But that should be correct because they didn't tell you to express things in terms of sine theta. If they said in terms of r and sine theta or r and sine 2 theta, for example, then it would be, you would have to do what we did, right? But just to prove to you that this is the same exactly as this, there's something called the double angle formula. Okay, so the double angle formula is basically cosine of 2 theta can be written in terms of sine squared theta. It's going to be 1 minus 2 sine squared theta. Now, this is something you learn in P3. You won't learn it in P1, but that's something, even in the formula sheet, you find this. So you can use that to change this into r sine theta, and I'll show you how. So first of all, I'm going to take out 2r squared as common in these two terms. I'm left with 1 minus cosine of 2 theta, and that's all over 2. Okay, it's just the square root of that top part. So you're going to have the square root of 2r squared, and I'm going to replace the cosine 2 theta with this. So this cosine 2 theta is going to be replaced by 1 minus 2 sine squared theta. And that's all divided by 2. That gives me the square root of, that's 2r squared, and you have 1 minus 1, which is 0, and minus gives you plus. So 2 sine squared theta over 2, which gives us, okay, that will give us the square root of, and that's going to be 4r squared sine squared theta over 2. And the square root of 4r squared sine squared theta is 2r sine theta divided by 2, and you're left with r sine theta. So this expression that we got here is the same as r sine theta, which is that length over there. All right, so it will actually give you the same thing. If you didn't understand what I did here, there's absolutely no problem until you get to P3. By simply just replacing the cosine 2 theta with 1 minus 2 sine squared theta. And where that comes from, this is not the place to explain. That comes later on in your maths journey when you do P3. But just to prove to you that this expression that we got for the length of the radius of this big circle written in this form is actually the same thing as this. Okay, so if you had written that down as if you'd written this minus, instead of this minus all of that, if you'd written, pi times, where did I write? I think I've got rid of it now. But if you wrote pi times this squared minus those same things, the answer will still be correct. But I advise you to just use a more simpler form like this. when you're answering such a question. So I hope that was clear, and it kind of dealt with the question that the student was asking me. This is a better way of writing your answer, and what you did was also correct, but I would stick to using something like this. All right, so that completes this question. Other questions from this paper, if I get to answer any of them upon request, you'll find in the playlist at the top right of the screen at the end of this video. Other questions from the topic of radian measure from my P1 collection of Cambridge can be found in the playlist at the bottom here. You can subscribe to my channel by clicking on this link, and on the top here you can watch a video which will take you to tell you how to use my channel efficiently. Thank you for watching, and see you soon.